Do you remember what the first airplane in the world looked like? Thinking about the shape of that first airplane and comparing it to modern aircraft, the transformation in appearance alone is remarkable, even before discussing technological advancements. Looking back over a century since the first airplane was created, we must acknowledge the brilliance of human intellect. Someone once said that every great invention proves humanity's limitless ability to conquer what once seemed impossible. Do you agree with that? Just as I'm curious about the stories behind these iron birds, are you interested in the wing design of the Vought F4U Corsair? You know, the Corsair's inverted gull wing design is one of the key features that made it a legend in aerial combat. But how exactly does this design work? Let's explore it right now. How does the inverted gull wing actually work? The F4U Corsair's inverted gull wing design shows a brilliant combination of aerodynamic principles and structural engineering. This creative design provided an elegant solution to multiple technical challenges. The Corsair's distinctive wing design achieved remarkable aerodynamic efficiency through its geometric configuration. A perpendicular angle between the wing and fuselage eliminated the need for drag-inducing wing root fairings. This perfect intersection minimized interference drag between these components. The unique shape of the wing incorporates both anhedral and dihedral sections, with the inner portion angling downward before curving upward toward the wingtips. This design enhances lift generation even at shallow angles of attack, reduces wingtip vortices to improve aerodynamic efficiency, and optimizes airflow around the junction where the wing meets the fuselage. Engineers cleverly built cooling systems into the wing's leading edge. They placed oil coolers and supercharger air intakes right into the anhedral inboard section. This smart design removed the need for external cooling scoops and cut down overall drag. The production team created groundbreaking methods to build the complex wing structure. They used a massive jig fixture assembly, something never seen before in aircraft manufacturing, to precisely join the wing's main spar and firewall bulkhead. This new tooling system helped maintain quality across thousands of aircraft. The wing's design incorporated several advanced features, including a variable lateral control linkage that enhanced maneuverability, wooden ailerons that allowed for quick aerodynamic balance adjustments, a fabric skin covering the outer wing sections beyond the main spar, and spot-welded aluminum panels that required fewer rivets for improved structural efficiency. Smart material choices and innovative assembly methods led to excellent structural efficiency. The wing housed landing gear components that rotated 90 degrees into fully enclosed wheel wells. United States Navy aircraft had never used such a system before. The inverted gull wing design brought some manufacturing challenges at first, yet its advantages proved worth the extra effort. The design allowed for shorter and stronger landing gear struts, facilitated an easier wing folding mechanism for carrier operations, provided greater structural strength under stress, and improved pilot visibility during critical flight phases. Combat operations proved the squadron's effectiveness, helping Corsairs achieve impressive kill ratios. During World War II, a single Corsair was credited with downing 11 enemy aircraft in the Pacific Theater. This success showed the engineering team's innovative approach had set new standards for fighter aircraft design. The wing's structure made maintenance and weapons integration easier. Natural break points in the wing's shape created perfect spots for service panels, simplifying routine maintenance. The design also allowed weapons systems to fit efficiently outside the landing gear assembly in the wing's folding section, overcoming challenges to create revolutionary solutions. Why the inverted gull wing design? This unique gull wing was the solution to the challenges engineers faced in creating the powerful Corsair. By late 1938, Chance Vought Aircraft was working with the Navy's Bureau of Aeronautics to design a high-performance carrier-based fighter. They chose a new Pratt Whitney engine that had been in development since early 1937. It's the R2800 Double Wasp. This powerful engine revolutionized aviation propulsion systems and completely transformed aircraft technology. To maximize its power, they selected a large Hamilton Standard hydromatic propeller. However, this powerful engine introduced several design challenges. Due to the propeller's large size, designing landing gear long enough to provide sufficient ground clearance became difficult. To solve this problem, engineers opted for an inverted gull wing design. The inverted gull wing setup lets engineers place the aircraft's armament outside the landing gear assembly in the wing's folding section. This layout made maintenance easier and boosted the aircraft's combat potential. Detailed design work began in June 1938 when the XF4U prototype contract was approved. The engineering team worked hard to maximize thrust while reducing weight and drag. Construction moved quickly since this was the first airframe designed specifically for the Double Wasp engine. The prototype first flew on May 29, 1940, with test pilot Lyman A. Bullard, Jr. in control. An unexpected landing due to elevator trim tab flutter didn't change the fact that the basic design worked well. The first F4U production model flew 2 years later on June 24, 1942. This marked a major breakthrough in naval aviation engineering. The inverted gull wing design came with pros and cons. Key benefits included less interference drag between the wing root and fuselage, plus reduced drag between the gear strut and wing. The design worked especially well for carrier operations by lowering folded wingtip height. These benefits came with certain trade-offs, including the need for a larger wing area to generate the same amount of lift, increased complexity in wing construction, and higher manufacturing costs. Nevertheless, the team's innovative solution tackled the original challenge of fitting the huge 13-foot 4-inch diameter propeller while keeping short, strong landing gear for carrier operations. The gull wing setup substantially improved the aircraft's center of gravity. This made it more stable during flight and carrier approaches. First flights and doubts. The F4U Corsair showed amazing speed capabilities, but carrier trials in 1942 exposed serious operational problems that put its future as a naval aircraft at risk. The United States Navy's excitement about the fighter turned to doubt as testing revealed multiple issues. But before we talk about the doubts of the customs, let's talk about the first flight of Whistling Death. It was a flight that risked lives to prove the new design. Do you think this is commendable? Let's hear about it and leave a review. On May 29, 1940, test pilot Lyman Bullard flew the prototype XF4U Corsair for its maiden flight at Bridgeport Municipal Airfield, Connecticut. The historic 38-minute flight began an intense testing phase that would test both the machine and pilot to their limits. The original test flight ended when high-frequency vibrations caused the aileron trimmers to fail at 370 kilometers per hour. Bullard needed to make an emergency landing. His skilled piloting brought the aircraft down safely, despite major control challenges. The next test flights revealed several issues that required immediate solutions, including engine overheating, inefficiencies in the fuel system, and undesirable wing stall characteristics at minimum landing speeds. The whole ordeal took a dangerous turn on June 12, 1940. Test pilot Boone Guyton tried an emergency landing on a golf course. His aircraft hit trees at 150 kilometers per hour, rolled over, lost a wing, and damaged its fin and propeller badly. Guyton survived, which showed both the risks test pilots faced and the aircraft's strong structure. Engineers installed a more powerful R2808 engine with 2,000 horsepower for October's test flights. The XF4U-1 reached a milestone on October 1 and became the first single-engine United States fighter to exceed 400 miles per hour in level flight. During their thorough evaluation, test pilots discovered Corsair's exceptional performance, demonstrating impressive speed and maneuverability, a climb rate of 810 meters per minute, and a service ceiling of 10,730 meters. Anti-spin testing brought new challenges. Pilots needed considerable physical effort to recover from spins. Engineers then developed a special anti-spin parachute system to help with recovery procedures. During early carrier qualification trials in 1942, pilots encountered several landing challenges. They struggled with limited visibility during landing approaches, oil from the cowl flaps obstructing the windscreen, and problematic undercarriage bounce characteristics that made landings more difficult. British Royal Navy pilots helped solve these carrier landing challenges. Their input led to changes that made the Corsair fully carrier-capable by late 1944. Colonel Charles Lindbergh served as a technical consultant and showed what the Corsair could do. In 1944, he flew with a 4,000-pound bomb load, matching twin-engine bombers. This feat proved the aircraft could do much more than just fight. Now let's get back to the Navy's suspicions that were mentioned a few minutes ago. Initially, the United States Navy was skeptical about the revolutionary design of the F4U Corsair, especially after carrier trials in 1942 revealed serious landing issues. Limited visibility due to the long nose, stiff landing gear that caused severe bouncing upon touchdown, and uneven wing stall characteristics led to its rejection for carrier operations. Meanwhile, the United States Marine Corps recognized the Corsair's potential for land-based missions, where its speed and agility proved invaluable in battles at Peleliu, Iwo Jima, and Okinawa. The Royal Navy's Fleet Air Arm introduced key modifications, such as softening the landing gear struts, adding a small wing spoiler for stability, and raising the pilot's seat for better visibility, which resolved many landing challenges. Additionally, British pilots developed a curved landing approach technique, allowing for better visibility of the landing signal officer, a method later adopted by the United States Navy. This led to the Corsair being approved for carrier operations in April 1944. As Japanese kamikaze attacks intensified, the United States Navy deployed Marine Corps F4U squadrons on fast carriers, strengthening their defenses significantly. Thus, the Corsair changed from a rejected carrier fighter to a key naval aircraft by using creative solutions and adapting to different roles. British engineers and dedicated Marine Corps pilots helped the Ensign Eliminator become one of World War II's best carrier-based fighters. What people say about the F4U Corsair. Speaking of this nickname, we must talk about the journey of the Corsair during World War II. If you've read this far, you might remember that we called the Corsair Whistling Death earlier. Do you wonder why it was given that name? Or if you know of any other origins for this nickname beyond the reason I'm about to mention, feel free to share it with us in the comments. When World War II broke out in Europe, the United States Navy requested upgraded weaponry for the Corsair. Vought equipped the aircraft with 650 caliber machine guns mounted on the wings. This modification led to the removal of wing fuel tanks, requiring an expansion of the fuselage fuel tank and shifting the cockpit 35 inches further back. This change made landings even more difficult, especially for inexperienced pilots. The design was approved for production in mid-1942, but when carrier landing tests were conducted in September of that year, The Corsair encountered issues with its landing gear, tail wheel, and arrestor hook. Since the United States Navy already had the F-6F Hellcat, the Corsair's deployment with the Navy was delayed until these issues were resolved. However, by late 1942, the Corsair was deployed by the United States Marine Corps in the Southwest Pacific Theater, and by 1943, it was engaged in large-scale combat in the Solomon Islands. With its high speed and powerful firepower, the Corsair quickly demonstrated its superiority over the Japanese Mitsubishi A6M0. The Corsair was also known for its distinctive sound, created by air rushing through its wing intakes at high speeds. Americans believed the Japanese gave it the nickname Whistling Death, but some sources suggest that the Japanese often referred to the Corsair as Sikorsky. Initially, only the Marine Corps operated the Corsair, but by 1944, the United States Navy had also begun using it on aircraft carriers, alongside the Hellcat, to defend the fleet against kamikaze attacks. The Corsair also played a significant role in ground attack missions, supporting Allied forces in campaigns across the Pacific, from Palau and Iwo Jima to Okinawa. That's how the enemy referred to the Corsair, but what did the pilots who mastered this aircraft say about it? Do you know any interesting stories? If so, share them in the comments. We would love to hear tales of heroism from the pilots who flew this legendary aircraft. And now, let's talk about the heroes behind the controls. First up is Lieutenant Kenneth Walsh. Lieutenant Walsh became the first Corsair ace and ended up claiming 21 aerial victories. His combat skills earned him a reputation as one of World War II's toughest and most aggressive pilots. Major Gregory "Pappy" Boyington led the VMF 214 Black Sheep Squadron to glory with 22 victories in F4U Corsairs before Japanese forces captured him. His squadron's achievements were remarkable, with 97 confirmed aerial victories in just 84 days. Boyington spent 18 months as a prisoner of war and later received both the Medal of Honor and the Navy Cross. First Lieutenant Robert Hansen showed his exceptional talent by taking down Japanese aircraft in groups of 3, 4, and 5. His impressive score of 25 victories made him the Navy and Marine Corps' most successful Corsair pilot. Several Corsair pilots earned the Medal of Honor through acts of valor that embodied military service's highest traditions. Lieutenant Thomas Hudner's actions stood out. His aircraft carrier captain called it the finest act of unselfish heroism in military history. Hudner crash-landed his Corsair on December 4, 1950, to save his wingman, Ensign Jesse Brown, America's first African-American Navy pilot. Kenneth Walsh's Medal of Honor came after an incredible battle where he faced enemy formations that outnumbered him 6-1. He destroyed 2 Japanese dive bombers and a fighter aircraft in a single mission. President Franklin Roosevelt honored Walsh personally with the nation's highest military award in the White House Oval Office on February 8, 1944. The Corsair's reputation rose to match the famous P-51 Mustang and P-38 Lightning, thanks to Medal of Honor recipients Pappy Boyington, Robert Hansen, and Kenneth Walsh, each with more than 20 victories. Memorable feats and post-war imprints. Finally, before we wrap up today's video, let's take a look back at the Corsair's most memorable achievements and its post-war legacy. The most remarkable feats of the Corsair were those it accomplished during World War II. On May 10, 1945, 2 United States Marine Corps pilots, Kenneth Reuser and Robert Klingman, intercepted a Japanese Kawasaki Ki-45 over Okinawa. After running out of ammunition, Klingman used the propeller of his Corsair to slice off the tail of the Japanese aircraft, causing it to crash into the sea. Despite sustaining damage, Clingman's Corsair managed to land safely. The Corsair achieved an impressive kill ratio of 11-1, with 2140 Japanese aircraft shot down while losing only 189 of its own. It also dropped 15,500 tons of bombs, accounting for 70% of the total bombs dropped by United States fighter aircraft during the war. The Corsair was the only World War II fighter to continue production after the war ended. It served in the United States Navy and Marine Corps until the 1960s. During the Korean War, the Corsair primarily faced off against the Yak-9. Pilot Guy Bordelin became the only ace to achieve 5 air-to-air kills using a propeller-driven aircraft during the conflict. The Corsair continued to serve in air forces worldwide, from France and Indochina and Algeria to Honduras during the 1969 Football War. In total, 12,751 Corsairs were produced in 16 different variants, making it the longest-produced piston-engine fighter in the United States history. Thank you for watching until the end of the video. If you have any interesting stories about the F4U Corsair, feel free to share them in the comments. Also, if you want to learn all the details about Corsair's design and performance, check out our channel. We've uploaded a detailed video covering that topic. See you in the next videos.